Hi everyone, welcome back to our channel. Today we are going to learn the MATLAB simulation of hybrid parameters. Okay, so now whatever the circuit here I am showing the same circuit we need to develop in MATLAB. So here you can see here this is a T network with series arms as 1000 ohm and next series arm as 1000 ohm and shunt branch as 500 ohm. Okay, and we are going to excite it input port and output port we are going to make it as short circuit. This we have to do it. So I think you know how to you have to short circuit at the output port, then you will be getting h11, the units are ohms. Then you are going to get the next one is h21, which is nothing but current gain. Okay, so this is nothing but h21, which is nothing but the current gain. Therefore the units are no units, and we have to develop another circuit where this is the another circuit. You have to make open circuit at input port and you have to evaluate h12 where the units are no units, and we have to evaluate h22 where the units are in mhos. Okay, so these are the two circuits you have to develop step by step. Let's try to go for the first one, MATLAB simulation of H parameter. Okay, so see here how to do it is first open the MATLAB window. Under this MATLAB window, just click on the simulation and window will be opened like this. Here just click a blank model. Okay, so here a blank model will be open. Just scroll it, keep it in the right hand side and minimize the original MATLAB. Just drag it as per your convenience to where you are doing the project. Okay, so just edit it like this and keep the another window in the next half. Okay, just minimize it and keep it in the next half. So this is what the circuit we need to develop. Let's try to check out what are the elements we are having. So we have an voltage source and resistances and one ammeter and one voltmeter and scope. Okay. So see here where to find these elements is go to click on the library. In the library we have to scroll down, go to Simscape. Okay. So in Simscape go to electrical. In electrical, go to specialized power system. Under this you have an fundamental blocks. Okay, under this fundamental blocks hold power GUI and drag it into the simulation block. Okay, so first thing the power GUI is completed, and next we require electrical sources. Here in the electrical sources, let's try to select the voltage source as the one source, and you require the elements. So here in the fundamental blocks, you have electrical sources and elements. So here in this element, you select the series RLC branch. Okay, you require an T network, and you require the come down. Here you will have measurements. Under this measurement we need to find out I1 and I2. Therefore I'm keeping an ammeter. I need to find out V1 also. Therefore I'm going to use voltmeter, and I want to see the output. The output I can see with the help of sync. So drag this display. Okay, and I require an gain. Therefore for this gain I'm taking the gain element. Okay, so this is the gain element. Okay, now later we'll see how to do the remaining thing. Okay, this is what we need to develop. That's why I drag all those components, and now I'm going to arrange. See here they are coming to the arrangement. So first keep the voltage source and double click on this series RLC branch, and the branch type you just label it as R and just click OK. And the value of this resistance should be 1000 ohm. So here come to here and write down this as a 1000 ohm and click on apply button and OK button, and at the bottom also just click it and write down as 1000 ohm. Similarly, copy this resistor and paste in the next half, and the value of this resistor is also 1000 ohm. Okay, so 1000 ohm, and we require one shunt branch. Therefore copy the same resistor, control C and paste here, and we need to rotate it. Click on the resistor and use control R button. Okay, automatically it will get rotated. Okay, so therefore you got the basic elements what we require. And now you can see here the diagram what we require is, so we need to connect an ammeter and voltmeter. Okay, so therefore check out where the ammeter is. Okay, so you require an ammeter. Similarly, go to library and go to electrical measurements. In these measurements, drag the ammeter and place in our target box. Okay, so here we need to find the currents I1 and I2. So therefore here I am connecting the ammeter. So connect positive to positive and negative to negative. Okay, and therefore this will find the current I1, and here you require one more current. Therefore control C, control V at the output we require. Let's try to connect it. Okay, so hold on this box and use the control R button. It will rotate from this positive to positive, connect to positive, and from negative to negative, connect to this negative, and from this negative to negative you short circuit it, connect positive to positive and negative to negative. That's how to construct this branch. If we want to see the output, connect the display here and just write down this is I1. Okay, and here also same, just copy it to control C and paste here as a control V, and just connect it and write on it as a I2. Okay, so now we require to measure the input voltage, which is nothing but V1 we require. Okay, so therefore connect positive to positive. So if it is a proper connection, it will show in black color, otherwise it will show in red color. So connect positive to positive and negative to negative. Okay, and this is the voltmeter you have got, and you have to see the output. So just to copy this scope and paste here, this will be the input voltage, which is nothing but V1. Okay, just like this you can label the components whatever you require. And you don't want gain, later we can see the importance of gain. Okay, so now in order to run it, let us try to see how we are going to get the parameters. Okay, so the basic h parameters we are going to have is so we are having the equations of v1 I1. Already theoretical calculations are there, you can check out in the link or in the channel. The theoretical calculations of h parameters already there. Okay, so we have v1 I1 as input and v2 I2 as output. We need to express the equation v1 I2. Okay, so v1 I2 are the dependent parameters. We require the first parameter is h11 multiplied with I1. Okay, plus h12 multiplied with v2. So next I2 you require. Okay, so h21 I1 plus h22 v2. So I will require the values of h11 and h22. I want to make these parameters as 0. Therefore, make v2 equal to 0. The meaning of v2 is 0 is the output port is short circuited. Therefore, the value of h11 we are going to get it as v1 by I1, and we require the value of h21. H21 is equal to I2 by I1. So these are the first two parameters we are calculating in this block. So we require I1 current, that's why we kept an ammeter. We require an I2 current, that's why we injected one more ammeter, and we require V1. Therefore, here you can check out now the simulation diagram. You'll be having all those parameters. Okay, so this is V1, I1, and I2. So now we need to give the connections for this multiplier. Okay, so first initially run it. What are the errors are there? Slowly we can solve it. Okay. So just you can see here at the top we have run button. Just run the button. Okay. So here it is showing that 100 volts, but actually you have to apply it as 30. Just change that value as 30, and just click on the apply button and OK button. And once again save the settings. Okay. So before you save, you can just save it later. So just run the button. So here it will be showing the currents, okay, and we need to verify the values of H11, okay, and as well as the values of H2, okay. So we need to have this. You can see the comparison of these parameters. So the original you have to get it as 0.02, and here the current as 0.075, okay. So 0.75, and you can see here the central branch is only 500 ohm resistor, okay. Now I think you'll be getting the required currents. Just run it again. So hope you had got these values 0.025 and 0.075. Okay. So now we need to construct the remaining part. Here you can see here we require one division and multiplication for this. Just to go to the library and check out the options of mathematical operation. There you are going to have divide and multiply. Drag it and keep it in your channel. And now let's try to have this untitled as v1 by i1. So this is the value of v1, okay. So connect v1 to here, okay. So this is v1 and i1. So this is the value of i1, okay. Therefore this is going to give the output. Just copy this and paste here and write down this is the value of h divided by i1. Okay, so just connect to this link, it will get connected. The next we require is h21. So once again use this block and paste it here. If you want you can drag it up, just paste it here. And here also you require i2 by i1, it's nothing but current again. So same, copy this and paste here, and here you are going to get h21, which is i2 divided by i1. Okay, so just connect this to this block. I2, where is I2? So this is the current I2, okay. So from here I2 you try to connect to the output, okay. So this is the value of I2 divided by I1. So this is the value of I1, or you can directly connect here, okay, and just run it. If you run it, therefore you are going to get the exact answers. H11 is equal to 1333 ohms. So here V1 by I1, this will be in terms of ohms, and H22 is nothing but current by current. There's no units, therefore you are going to have no units. So like this, you are going to have the multiple parameters. So that's why we first performed this calculation, which is nothing but V1 by I1 as well as I2 by I1. So now we are going to perform the next half. So I want the value of H12. So therefore I have to make I1 is equal to 0. When you make I1 is equal to 0, which is the meaning is that input port is open circuited, therefore you are going to get the value of so when you make this, automatically these two terms will become 0. Therefore you are going to get h12 is equal to v1 by v2 as well as h22 is equal to i2 divided by v2, okay. So this will be in terms of mhos, here no units. So in order to design this, we have to make the input port as open circuited. Now let's try to construct this diagram, okay. So let's try to scroll down. So all the elements what we have is already sufficient, just copy and paste, you can get this, okay. Now let's try to see the next block. So this is the block we need to construct. Same elements are there, just connect as per the requirement of v1 as well as v2, okay. So we require the values of v1 and v2, and we require the values of I2 and V2. Now just you see here two voltmeters at two sources and one ammeter at output port. Okay, so one ammeter at output port, input voltage and output voltage. Okay, so the same block you have to construct. Okay, just keep it aside and let's try to design it as this. Okay, so just move it down. So just copy this T network and paste in the bottom. Okay, Control V, and automatically it will create a down column. Control C, Control V. Okay, and here we'll be getting the network. So this is the shunt branch. Move it down, and then you can have better clarity. Okay. So these are the elements, and this element also you copy and paste it here. Okay, and this voltage source here, you can see here input is open circuited. Okay, so therefore you don't need to connect the input, and we have to excite it only at output. Just copy it, place at the output side, and take this voltmeter also, and let's try to connect. And we require one ammeter. Take this ammeter at output port and just connect it output port. Now let's try to give our connections. So these are the three elements we are having. In these three elements, you can see the original network. Here also we are having three elements. We require an ammeter at this side. Okay, so first let's try to, you can see here supply is from this side. Automatically current will move in this side. Therefore, just to hold this block and rotate, use Control R. It will rotate. Connect positive to positive, and from negative to negative connect to resistor, and from resistor to resistor you connect here, and from here you can make it as open, and from negative to negative connect here, automatically it is open. If you want to show that open, just copy it, paste it here, and here you can see here, just connect this element. Okay, so now it is just open, there is no use. Okay, so here you are going to get the current. So let's try to copy the result. Control C and just paste it here, and try to rotate. Okay, so just connect it, and this will be acting as I2. So I2 output current, just why, because already we have the name output current. So now, and we require V1 and V2. So it's already defined as 30. Just to connect an voltmeter, connect an ammeter, and connect to the scope. Okay. So take this value, just copy it, and we just paste here. So this will be acting as output voltage V2. V2 output voltage, and now we require input voltage also, but here you can see the circuit diagram. We require the values of V1 by V2 as well as I2 by V2. So therefore V2 is very clear, and we require the value of V1. So V1 will be across. So here you can see here, actually V1 should be there here, but whenever you make it open, current is 0. 0 into R is once again short circuited, and the voltage will be available here. Therefore just use this voltmeter and you connect here. Okay, so when we have connect this voltmeter here, so connect positive to positive, negative to negative. Okay, therefore you are going to get the output. Just copy it and paste here. Therefore here you are going to get the output, where this is called V1, where this is called input voltage. So therefore once you run it, then you can understand what kind of. So this is 30 no, 20 has been dropped, and available is only 10 volts, and we need to connect. You can see the same here. So here also you can see here, as soon as you run it, you are going to get all these parameters. Okay, so 30 is there, and here it is nothing but 10, and we require h12. Okay, so h12 means here just take that multiplier, just use control C, control V, take this output, control C, control V, and here you define as h12. h12 is equal to v1 by v2, v1 divided by v2. So check out where v1 by v2 is there. Okay, so here this is nothing but v1 by v2. Wait, this is nothing but v2. Okay, so v1 by v2 is nothing but voltage by voltage, no units. So just you can run it. And next, once again copy it and paste here, and next we require h22. Okay, so just a copy, control C, control V, therefore you are going to get h22. So h22 you are going to get I2 by V2. So this is I2 by V2. Okay, so just connect this to this one. Where is I2? So this is I2, right? So just connect to I2 by V2. V2 is nothing but the bottom one. Okay, so this is the V2 value, just the same denominator you'll be getting. So just run it. So you can see the answers h12 as well as h22. h12 is nothing but 0.34 no units. h22 is 0.006 in terms of Mohs. Okay, so that is how to simulate. So hope we are able to understand. Just first connect a voltmeter. Why I connected the voltmeter is here I require the ratio of V1. Why I connect the voltmeter is here I require the voltage V2, and you require the current. Therefore I connected here. Okay, so sometimes when you click here, it is showing that non-formatable. You just right click on this button, then you can get the help. Okay, uncomment, just remove the uncomment, automatically it will display the current. Okay, so slowly you can rearrange as per to make the diagram neat. So this is nothing but we are making input as open circuited, and we are finding h12 as well as h22. Okay, so if you want you can understand. So V1 we are making, I1 we are making 0, therefore we are getting H12 as well as H22, and we are making V2 equal to 0 in the first step, V1 by I1. So hope you are able to understand. And these are the diagrams for I1 is equal to 0, and when you go up, this is the diagram for by making V2 equal to 0. Okay, so hope you are able to understand the simulation. So this is the process of doing. So if you want theoretical analysis, you can watch in my channel. All the theoretical analysis are there, or otherwise I will attach in the link in the next video. You can check out there. If you feel my explanation is good, please like the video and share with your friends. If you have any doubts, let me know in the comment section. And if you are watching my channel for the first time, subscribe to my channel with the name KV Tulasiram. Kindly support this sort of a free channel for the development of students and faculty. Thank you for watching. We'll meet in another good simulation.